Long before the modern human world took shape, South Asia was already a crossroads of hominin pioneers. There were shifting coastlines, erupting volcanoes, and moving populations that crossed land bridges or paddled along coastal strands. Among the islands that rose from this tectonic cauldron, Java stood in a singular position. While later millennia would see Sundaland drown beneath rising seas, the late Pleistocene instead offered connections and corridors, inviting movement across what are now separate islands. Human populations, archaic and modern, converged here in a landscape shaped by dramatic climate swings. Java was not a backwater of human evolution, it was a stage where multiple ancient lineages met, mixed, and sometimes vanished. The possibility that early Homo sapiens reached Java more than 100,000 years ago is no longer radical. Fossils from East Asia push the range of early expansions far beyond the once-favoured 70,000-year threshold. These early pioneers did not leave lasting lineages in most regions, but they represent attempts by modern-looking humans to spread beyond Africa long before the main dispersal. When these pioneering populations pushed east, it is plausible that some reached the Great Sunda Plateau, a contiguous landmass connecting mainland Southeast Asia with island regions that today are separated by narrow straits. Java lay near the centre of this landmass, a node where rivers from the interior poured into coastal plains teeming with herbivores and predators. If an early Homo sapiens group established itself here roughly 120,000 years ago, its arrival would not have gone unnoticed by the hominins already present. The Solo River region is one of the richest Pleistocene deposits known from Indonesia. The skeletal remains found at Ngandong along its banks have traditionally been assigned to Homo erectus, but their morphology sets them apart. The crania are larger and more rounded than classic East Asian erectus, the vaults higher, the posterior squama more modern in curvature. Although classified as late Homo erectus, they share striking similarities with early Homo sapiens, particularly Omo II from Ethiopia.
Omo II was down here with one relationship to Iwu Uleru, but also with a kind of perhaps striking resemblance to the Solo Homo erectus crania from Indonesia.
Indeed, the resemblance has prompted some paleoanthropologists to wonder whether these skulls belonged not to a lingering archaic species, but to an early modern population that reached Java well before the conventional timelines suggest. In fact, several researchers classified the Java skulls as Homo sapiens soloensis due to their modern features. The dating of Ngandong, now confidently placed at roughly 117,000 to 108,000 years ago, aligns closely with the proposed time window for early Homo sapiens excursions beyond Africa. This alone makes Solo Man chronologically compatible with an early sapiens identification. If the Ngandong crania were found in Africa, few would have hesitated to assign them to early Homo sapiens or transitional forms. Their designation as late Homo erectus owes much to geographical expectations rather than pure anatomical assessment. Once this bias is recognized, the hypothesis that a small Homo sapiens group reached Java before the main out-of-Africa pulse becomes increasingly plausible. Yet the story does not end there, for Java was not empty when these early modern people arrived. Southeast Asia had already hosted archaic populations for hundreds of thousands of years. The lineage historically labelled Homo erectus had taken root, but Denisovan-like hominins must also have been present. Genetic evidence extracted from living Papuans and Aboriginal Australians reveals surprisingly high levels of Denisovan ancestry, far exceeding that found in other modern human populations. Moreover, these Denisovan signatures appear to derive from at least two distinct lineages, implying that Denisovans were not a single homogeneous group. One lineage, labelled as D2, appears to have been located in Sundaland or mainland Southeast Asia, while another Denisovan lineage D1 lived in Papua or northern Australia, known as Sahul. These discoveries reinforce the notion that Southeast Asia was home to multiple archaic populations whose identities and interactions remain poorly understood. In this setting, early Homo sapiens arriving around 120,000 years ago would have faced competition from resident hominins. They might have also faced opportunities to exchange genes. The archaeological and fossil record from Java during this time is sparse, but the Ngandong horizon stands as a solitary beacon, hinting at a population that flourished for a time before disappearing. If these people were early Homo sapiens, their disappearance could reflect absorption into local archaic groups or extinction through competition or assimilation. The possibility that they became integrated into resident Denisovan-like populations offers an intriguing explanation for the faint traces of early Homo sapiens ancestry detectable today in people of Papua New Guinea. One study suggested that Papuans carry up to 2% of ancestry from an earlier modern human pioneer group, perhaps 120,000 years ago. Some have questioned this result, but nonetheless the signal remains, and its presence demands an explanation. To evaluate this possibility, it is necessary to consider the environmental pressures of the late Middle Pleistocene. Around 120,000 years ago, the world saw the peak of the last interglacial period. Sea levels rose, flooding low-lying areas of Sundaland and reducing the distance between coastal populations. While earlier glacial periods had exposed vast continental shelves, turning much of the region into a connected subcontinent, interglacial flooding fragmented these land bridges and forced populations into closer contact along the remaining habitable corridors. As water levels rose, coastal plains shrank, river valleys narrowed, and ecological niches contracted. The populations occupying Java during this time would have been compressed into smaller, more resource-dense territories. In such conditions, competition between hominin groups would have been intense. The southern Denisovan populations, which had already adapted to Asian environments for hundreds of thousands of years, and carried around 10 to 20% Neanderthal ancestry from earlier northern interactions, would have been physiologically and behaviorally suited to these shifting landscapes. If early Homo sapiens arrived with smaller numbers and without specialized adaptations to the region, they found themselves at a disadvantage. Over generations, these incoming groups could have been absorbed into the local gene pool. Humans with hybrid ancestry might have been better adapted to local pathogens, climate and food. Natural selection could have further favored traits inherited from Denisovans or Neanderthals, slowly diluting the presence of early modern human genes. In this scenario, the Ngandong population represents a hybridizing frontier where early Homo sapiens and local Denisovan-like peoples interacted. Hybridization need not have been symmetrical. In small incoming groups, with only limited numbers of females or males, the genetic signature of the newcomers can be overwhelmed by that of the residents. In many cases, only a sliver of their genetic legacy persists. This pattern matches what is observed in Papuans, where the early modern signal, if it exists at all, is faint. The bulk of the archaic ancestry in Papuans appears to derive from Denisovans, and in particular from a lineage that diverged from the Denisovan genome identified in Altai. This implies that the Denisovans who interbred with the ancestors of Papuans were local to Southeast Asia. If these local Denisovans absorbed early Homo sapiens populations like those at Ngandong, the resulting hybrids would have carried a mosaic of genes reflecting this encounter. Archaeological assessment of the Ngandong material adds another intriguing dimension to this hypothesis. The 12 solocrania were not found as whole skeletons, but as isolated skull caps, deliberately modified and deposited together in a manner unlike typical natural accumulation. Several researchers have noted their patterned placement and the absence of associated long bones, suggesting they represent collected trophies rather than simple burials. If these skulls were indeed curated, transported or displayed, they speak to a social context in which one population actively targeted another. Ralph von Koenigswald, the original discoverer of the fossils, and one of many researchers to have classified these skulls as Homo sapiens soloensis, suggested that they had been the victims of an assault by another tribe. Perhaps the horde was taken by surprise and fled. Perhaps the skulls were put down to mark off the area. It seems that even today, various tribes in New Guinea demarcate their dwelling or hunting grounds in a similar manner. They evidently suppose that the spirit dwelling in the skull can help them to defend a particular area against invaders, he wrote. Von Königswald made note of major injuries in skulls 4 and 6, which he believed were caused by a cutting instrument and a blunt instrument, respectively. They bear evidence of inflammation and healing, so they probably survived the altercation. Von Königswald noted that only the skull caps were found, lacking even the teeth, which is highly unusual. So they interpreted skulls 4 and 6 as victims of an unsuccessful assault, and the other skulls, where the base was broken out, the result of more successful attempts to slay the victims, presuming this was done by other humans to access and consume the brain. They were unsure if this was done by a neighbouring tribe or by more advanced human beings who would have given evidence of their superior culture by slaying their more primitive fellows man. Such treatment implies conflict and intentional removal of heads, perhaps as symbols of dominance or ritual protection against the spirits of the defeated. This interpretation aligns with a scenario in which Denisovan-derived groups, already acclimated to Java, confronted incoming early Homo sapiens and ultimately overcame them. Trophy-taking would document not only violence, but a cultural recognition of difference, a sense that these others were distinct and perhaps threatening. If true, the Ngandong assemblage preserves one of the earliest archaeological hints of inter-hominin warfare, marking a moment when hybrid Denisovan Neanderthal groups asserted territorial supremacy over the newcomers long before modern humans later repeated similar patterns elsewhere across the world. The main wave of modern humans did not reach Southeast Asia until perhaps 60 to 50,000 years ago. By then, if the Ngandong early sapiens population had been absorbed, the newcomers would have encountered hybrid archaic populations rather than pure Denisovans. The new group would then have added yet another layer of complexity, mixing with these hybrids and picking up Denisovan and Neanderthal genetic material before crossing into Sahul. The settlement of Australia and New Guinea would have carried this ancient admixture into geographic isolation, preserving the record of these deep interactions, including 2% early Homo sapiens, 5% Denisovans, and 2% Neanderthal. Java, therefore, may have been a crucial node in this network of encounters. Its location on the western edge of Sundaland, coupled with fluctuating sea levels, created alternating periods of isolation and contact. During glacial periods, low sea levels connected Java to mainland Asia, enabling hominins to move southward along forested plains. Rivers guided travellers toward fertile floodplains where game animals congregated. During interglacials, rising seas severed these land connections, trapping populations in newly insular environments. These fluctuations could have facilitated repeated pulses of contact between groups, while also creating refugia where hybrid populations persisted in isolation. The Solo River Terrace, with its layered sediments and rich faunal remains, speaks to a lush environment that would have supported substantial hominin populations. The presence of large herbivores like water buffalo and stegodons suggests that the region offered a dependable source of food for hunters. If early Homo sapiens established themselves here, they would have had the opportunity to thrive. Yet the same resources would have attracted resident Denisovan-like populations, setting the stage for competition. The absence of later Homo sapiens fossils at Ngandong and the lack of distinctive tool assemblages linked to early modern humans could indicate that these populations did not persist. Instead, the archaeological record suggests a relatively abrupt end to the Ngandong hominin occupation. One possible explanation is a population replacement. Denisovan-Neanderthal hybrids outcompeted the early Homo sapiens groups. These hybrids, equipped with adaptive insight from both archaic and early modern lineages, may have been more capable hunters, better at navigating the local ecology, or more resistant to tropical diseases. Over time, they could have supplanted the earlier arrivals, either driving them into marginal habitats or assimilating them entirely. Such a scenario finds a parallel in later human history, when the main wave of Homo sapiens entered Eurasia and ultimately replaced Neanderthals, despite interbreeding. Hybridization and extinction can unfold simultaneously, leaving only traces of the displaced group's genes. In the case of Solo Man, the genetic legacy of early Homo sapiens could have been reduced to a faint signal within a primarily Denisovan-derived genome. This would align with studies suggesting that Papuans carry a small fraction of ancestry from a deep branch of early Homo sapiens, separate from the main out-of-Africa diaspora. As the Ice Age deepened again after the interglacial peak, sea levels once more fell, re-exposing Sundaland and re-establishing land connections with the Asian mainland. This new connectivity would have allowed further Denisovan-derived populations to spread onto Java, overwhelming any remaining early Homo sapiens groups. If the D2 Denisovan lineage was concentrated in Southeast Asia, this dispersal could have extended the hybrid populations across coastal and inland corridors. Later Homo sapiens, arriving tens of thousands of years afterward, would encounter not distinct archaic species, but highly admixed populations that carried traces of both Denisovan and early Homo sapiens ancestry. Java's geological and ecological dynamism further shaped this process. The island's volcanic activity continually reshaped its landscapes, altering river courses and burying settlements. Eruptions could have caused local extinctions or forced population dispersals. The dramatic geologic record of Java, marked by eruptions like Toba farther afield, reminds us that hominin populations often faced sudden environmental challenges. The ability to relocate swiftly, adapt, or integrate with neighbors would have been crucial to survival. In this context, the early Homo sapiens of Ngandong, if indeed they were modern humans, may have been overwhelmed by environmental disruption as well as competition. The idea that Soloman represents an early Homo sapiens group absorbed or extinguished by Denisovan Neanderthal hybrids is, of course, a hypothesis. It rests on the convergence of several lines of evidence. The morphological similarity between Ngandong and early African Homo sapiens, the chronological alignment with early expansions out of Africa, the genetic signals in modern Papuans that hint at deep admixture, and the recognition that Southeast Asia hosted multiple archaic hominin lineages. It also acknowledges the dynamic interplay between climate, geography, and population movement that characterized the Pleistocene. While direct ancient DNA from Ngandong remains unlikely due to tropical conditions, the genetic signatures in living populations offer the best window into these ancient events. If future discoveries confirm that the Ngandong population was indeed an early Homo sapiens group, it would redefine our understanding of human dispersal. It would imply that early humans made significant inroads into Southeast Asia long before the main dispersal event. It would also suggest that the story of these early peoples is not one of simple failure, but of transformation. Their genes, though diluted, still persist in the Denisovan ancestry of Papuans and Australians, offering a faint echo of their existence. This perspective urges us to see human evolution not as a sequence of discrete species replacing one another, but as a tapestry woven from many threads, each contributing to the ultimate fabric of modern populations. Java, poised between continents and oceans, emerges as a crucible of this tapestry. It was a land where ancestral currents collided, where early Homo sapiens stood face to face with Denisovan and Neanderthal relatives. Its river valleys and volcanic hills bore witness to encounters that shaped the genetic heritage of populations far to the east. The island's unique position within Sundaland, combined with the rise and fall of seas, forged conditions ripe for interaction and integration. As sea levels rose around 120,000 years ago, the shrinking landmass compressed populations, intensifying contact. The influx of early Homo sapiens would have sparked new dynamics, perhaps triggering conflict or exchange. The eventual disappearance of the Ngandong population reflects the relentless processes of evolution, where groups merge or vanish, leaving only faint shadows in the genomes of their descendants. The story of Soloman remains incomplete, awaiting more evidence from excavations, improved dating, and genetic insights. But the hypothesis that Java was a meeting ground of early Homo sapiens and archaic hominins invites us to reconsider the complexity of human evolution in Southeast Asia. It suggests that the first modern humans to reach these shores did not simply fade into oblivion. They became part of a larger narrative of hybridization and adaptation. In doing so, they helped shape the very populations that would eventually populate Sahul and later still spread across the Pacific. In the end, The Ngandong fossils stand as a tangible reminder of a forgotten chapter in human history. They represent a people who lived at a time of profound transition, when seas rose, climates shifted, and hominin populations converged on the Sunda Plateau. Their fate, entwined with the Denisovan-derived groups that succeeded them, underscores the intricate web of relationships that define our species' past. Java was not merely a boundary between land and sea. It was a boundary between ways of life, a place where different branches of the human family collided. The legacy of those collisions endures today, preserved in the genetic mosaic of Papuans and Australians who carry within them the distant echoes of solo man and the hybrid populations that shaped their ancestry.